Hello and welcome in the part 3 of the chapter number 2, periodic classification of the elements. In second part, we have seen the modern periodic table. In modern periodic table is divided in 4 blocks: S block, D block, P block and F block. I told you the idea to remember this. Yes, Daddy, Papa and Father. Now we are going to see the properties of modern periodic table. We have first group, second group, then 17 and then 18 for the study. So now let's see the first one. The first group is known as an alkali metals. Which are they? Hydrogen, lithium, sodium, potassium, rubidium, cesium and francium. If you see the electronic configuration of these two, all these 7, you will find that in their outermost shell, it means its electronic configuration is 1. Lithium has electronic configuration 2 and 1. Sodium, its electronic configuration is 2 and 1. Potassium, it is 2, 8, 8 and 1. C in the outermost shell, there is 1 electron. Therefore, their valency is 1. But the question comes, why they are called as alkali metals? Because all the metals dissolve in water and therefore they are called the alkali metals. And I told you how to remember these alkali metals. Hari Naki Rab se faryad. Now let's see the second group, which is called alkaline earth metal. In alkaline earth metal, you will find that there are 6 elements: barium, magnesium, calcium, selenium, barium and rhenium. If you see why they are in second group, because see, the barium has atomic number is 4, so its electronic configuration is 2, 2. Magnesium, its electronic configuration is 2 and 8, 2 because its atomic number is 12. So 2, 8, 2. Observe this, in the outermost shell there are 2 electrons, therefore their valency is 2 and therefore they are in second group. But again the question comes, why they are called the alkaline earth metals? See, barium does not dissolve in water. Magnesium reacts with the steam, and calcium, selenium and these elements reacts with the water, less in water. Therefore, they are called alkaline earth metals. Now, we are going to see the next group, which is 17 group. Now it's called as halogens. See, which are the halogens? Fluorine, chlorine, bromine, iodine, astatine and tellurium. The first one, it's a fluorine. Its atomic number is 9. Chlorine have atomic number 17. Bromine, it has atomic number 35. Its electronic configuration is 2 and 7. Its electronic configuration is 2 and 8, 7. Its electronic configuration 2, 8, 18 and 7. See the outermost shell? There are 7 electrons. So they need 1 electron to complete their octave. Therefore their valency is 1 and therefore they are called the halogens. Now but see, fluorine and chlorine are the gases. Bromine in liquid state and iodine, astatine, these are in solid state and all they have valency 1. But I told you the idea to remember this one. First class biryani item at a time. First class biryani item at a time. So let's see the next part of this modern periodic table is 18 group. That is called noble gases. Why they are called noble gases? See the helium, neon, argon, krypton, xenon, radon, and these are the elements. It's helium, then neon, its atomic number is 2, its atomic number is 10, its electronic configuration 2, its electronic configuration 2 and 8. Then it is 18, therefore it is 288. See in outermost shell, there are 8 electrons. Therefore their octave is complete and therefore their valency is 0. And their valency is 0, therefore they are not gaining, they are not losing, even they are not sharing the electrons, and therefore they are not taking the part in chemical reaction. Thus they are called the noble gases or inert gases. Now remember this. I told you how to remember these noble gases. That is fantastic idea. Hina, Neha, Arti, Kirti, Jena, Rena and Oga. If you remember like this, then 18 group you will remember it. Now see, in modern periodic table, I have shown you the electronic configuration of some groups. In first group, I told you, see hydrogen, lithium, sodium and potassium. If you observe this, all have one electron in outermost shell. They in second group all have second 2 electron in outermost shell. Therefore they are in second group, they are in first group. Same like as up to the 18th group I have shown you. Argon, its octave is totally completed, and this is a potassium. In potassium, in outermost shell, there is only 1 electron. This is the electronic configuration from first to 18th group. Now let's see the next part of this chapter, and which is very important. Atomic size of the element. Exactly what is atomic size? And it depends upon atomic size of element. It depends upon its radius. Then what is radius? Radius is nothing but the distance between the nucleus and the outermost shell, and this is called a radius. And atomic radius is expressed in the unit picometer, and 1 picometer is equal to 10 raised to minus 12 meter. Remember this atomic size, because they will ask you the 2 questions which depend upon this one. Now let's see the next part, and that is atomic size in period. Now observe this period. You will find that potassium, calcium, scandium, titanium, and these are these. Now we are going to see the atomic size in the period. Actually, they will ask you to give the reason why atomic size in a period decreases from left to right. The first 2 points I told you already. The atomic size of the element, it depends upon its radius. Second point, radius is nothing but the distance between the nucleus and the outermost shell of the element. And then third point you have to remember, C. This is potassium having the atomic number 19, then calcium atomic number 2. What you observe here? In a period from left to right, the atomic number is increases. If the atomic number is increases, therefore 1 electron is added in outermost shell. And if the electron added in outermost shell, the positive charge of the nucleus increased by 1 unit. And if the nuclear charges increased, then electron gets pulled toward the nucleus with a great extent, and therefore atomic size decreases in period from left to right. Again, I am going to tell you in shortcut, atomic size of element it depends upon the radius. Radius is nothing but the distance between the nucleus and the outermost shell. In a period from left to right, the atomic number is increased. Therefore, one electron is added in the same shell. Therefore, the positive charge increases by 1 unit and the nuclear charge increases. Therefore, electron pulled toward the nucleus with a great extent. Therefore, atomic size in a period decreases from left to right. Now, let's see the next point of this. The same point, atomic size in groups. Now, observe this group. This is the first group which have hydrogen, lithium, sodium and potassium. Now, observe this. It has atomic number 1, it has atomic number 3, it has atomic number 11. So, what do you observe? This is 1, electronic configuration 2, 1. This is 2, 8, 1. What do you observe? What? The first point you have to write it as it is. Atomic size of element depends upon its radius. Radius is nothing but the distance between the nucleus and the outermost shell. While going down in a group, the shells are increasing. It means a new shell is added, and therefore the distance between the nucleus and the outermost shell is increased. Now, for this one, if you observe for the hydrogen, this is the one shell. For the lithium, it has, and then sodium for this one. See that it has two shells, and therefore shells are increasing. And if the shells are increasing, the distance is increased here, and therefore atomic size in group increases from top to bottom. Okay. Now let's see the next point, which is in atomic, which is related. I told you last time, which is related to the modern periodic table, which is called a zigzag line. A zigzag line divides the metal and non-metal, and on the corner of the zigzag line there are some metals which are called metalloids, that is silicon, germanium, arsenic, tellurium and polonium. This is a zigzag line. Last time we have seen in modern periodic table. Now, the same thing, next property is a metallic property. Why we are calling some elements are metals and some elements are non-metals? The elements who lose the electrons are called metals, and who gains the electron are called non-metals. So, we have to see the metallic property. Metals have tendency to lose the electrons. Now, same thing what you have seen about the atomic size, same thing happens here. In a period from left to right, the atomic number increases. If the atomic number is increases, the one electron get added in a same shell. And if the electron get added, it means nuclear charge added. If the nuclear charge is adding or increasing, therefore all the electrons get pulled toward the nucleus with a great extent, and therefore the same thing about the metallic property and atomic size is decreasing from left to right. So point you have to remember, metals have tendency to lose the electrons. Second, in a period the atomic number increases, thus electron get added in outermost shell. Third, therefore electrons are pulled toward the nucleus. As a result, metallic property decreases from left to right. This is called, and opposite to this one, you can say that non-metallic property increases. If the metallic property decreases, it means non-metallic property increases. And now the last point of this one is the valency. You have studied about that valency. What is valency? Valency is nothing but the combining capacity of the elements. Definition you have seen. Combining capacity of an element is called valency. There is another definition of the valency. To complete the octave, how much electrons they need, and that is called a valency. So see this one, all have one electron in outermost shell, therefore they lose the one electron to get the complete octave, and therefore they have the valency 1. Same thing, you will find that in a period atomic number increases, the valency is increasing. 1, 2, 3, 4, and after that it is decreases, because 5, 6, 7 and 8 it decreases up to the group 18. This is about the valency. Now I know that you enjoyed this chapter very well. Thank you, students.